Welcome to the TOEFL Listening section. In this section, you will listen to an academic lecture and then answer questions about what you heard. You may take notes while you listen. You will have time to review your notes before answering the questions. Listen to part of a lecture in a university class. You will hear the lecture only once, so listen carefully. After the lecture, you will answer some questions about what you heard. Some questions ask about the main ideas and supporting details. Other questions ask you to make inferences or connections between ideas. Answer each question based on what is stated or implied in the lecture.
Good morning, everyone. Today, we will examine adolescent brain development and its implications for cognition and emotion during the teenage years. This period is a distinct phase in neurodevelopment and demands its own theoretical and practical attention. To begin, we need to consider two major biological processes. The first is synaptic pruning. During adolescence, the brain eliminates weaker synaptic connections while preserving and strengthening more useful ones. The second process is myelination. This increases white matter and improves the speed and efficiency of neuronal signaling. These processes have regional variation. Cortical gray matter, especially in frontal regions, peaks in early adolescence and then declines as pruning refines networks. In contrast, white matter increases through the late teens and into the 20s as axons become more myelinated. The prefrontal cortex is especially important for executive functions like planning, impulse control, and working memory. It is one of the last brain regions to fully mature. By contrast, the limbic system, which includes structures such as the amygdala and ventral striatum, matures earlier and shows heightened reactivity to emotional and rewarding stimuli. This developmental mismatch produces a characteristic pattern. Adolescents often demonstrate strong emotional responses and high reward sensitivity at the same time that their cognitive control systems are still developing. That imbalance helps explain increased propensity for risk-taking and intense peer influence during adolescence. Neurochemistry plays a role as well. Dopaminergic systems undergo changes that amplify reward-related signaling. Dopamine spikes in response to novel and social rewards. This biochemical environment makes rewarding activities feel especially salient for teenagers. Let me give a concrete example. Several studies using functional MRI and behavioral tasks have shown that adolescents take more risks on a simulated driving task when peers watch them. The same adolescents perform better on response inhibition tasks when given explicit cues to engage control, which suggests that cognitive control can be recruited but is not yet automatic. A longitudinal MRI study following adolescents from age 12 to 20 showed cortical thinning in frontal areas that correlated with improved decision-making. This suggests that pruning is not simply loss, but an optimization process that supports more efficient cognition over time. Hormonal changes of puberty interact with neural development. Sex hormones can modulate the timing and expression of synaptic remodeling and can influence emotional reactivity. Thus, biological, psychological, and social factors converge to shape adolescent behavior. There are practical implications for education and policy. For example, delayed school start times can align with adolescent circadian shifts and improve attention. Graduated driver licensing systems that limit peer passengers reduce crash risk during the period when reward sensitivity is high and cognitive control is developing. Interventions that strengthen executive function show promise. Cognitive training, structured decision-making programs, and family-based communication strategies help adolescents practice regulatory skills. Importantly, these approaches respect the plasticity of the adolescent brain and use that window to support better outcomes. To summarize, adolescence is marked by synaptic pruning and increased myelination that refine neural circuits, a temporal mismatch between earlier maturing limbic regions and later maturing prefrontal regions, and neurochemical changes that heighten reward sensitivity. Together, these changes explain many cognitive and emotional features of adolescence and point to targeted supports for teens. If you are designing research or policy related to adolescence, keep in mind both the risks and the opportunities created by this developmental stage. The brain is changing in ways that make teens more vulnerable in some contexts and more adaptable in others.
Listen again to part of the lecture, then answer the question.
The prefrontal cortex is especially important for executive functions like planning and impulse control. It is one of the last brain regions to fully mature. By contrast, the limbic system matures earlier and shows heightened reactivity to emotional and rewarding stimuli.
This concludes the listening section. For more TOEFL practice tests and study materials, visit Spinta.org.